Good afternoon, my dear students. Today, let's discuss about electrostatics. Here, electro refers to the electric charge and statics refers to rest. That means, electrostatics is the branch of physics which deals with the study of electric charges which are at rest and their interactions. Basically, here we are going to concentrate on the frictional electricity, properties of these electric charges, Coulomb's law in vector form, units of charge, relative permittivity or dielectric constant, continuous charge distribution. And in that, we have the three types of continuous charge distributions, mainly linear charge distribution density, surface charge density, and the volume charge density. So here what is frictional electricity? So to study about the frictional electricity, we have a concept. Let me consider, if I take any object or any atom, the atom as a whole, it will be electrically neutral. That means there will be equal number of protons and equal number of electrons. So the net charge will be zero. Similarly, if I take another material, that will be also having the atoms which are electrically neutral. For example, here I am considering glass rod and a silk. If I take a glass rod and rub it to the silk, there will be exchange of charges. That is, the charges from the glass rod will be moved to the silk. Since the electrons have the higher mobility, electrons from the glass rod will start to move towards silk. And now, when the glass rod loses the electrons, there will be more number of positive charges than the negative charges in this glass rod. So this glass rod becomes positively charged. Whereas this silk which gains the electrons, that is which gains the negative charges, will become negatively charged body. And this is how we can charge a body by friction. This is what we call as the electrification by friction. Similarly, if I take evanite and rub that with Fresnel, or if I take some other materials, like I would like to give certain examples. Here I am considering glass and the silk. If I rub glass with silk, glass becomes positively charged, whereas silk becomes negatively charged. If I rub an amber with the wool, ಆಂಬರ್ ಮೀನ್ಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಆಸ್ ಅಂಟು, ಜಾಲಿ ಗಿಡದಲ್ಲಿ ಇರುತ್ತಲ್ಲ ಅಂಟು, ಅದಕ್ಕೆ ಆಂಬರ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ನಾವು ಇಫ್ ಐ ಟೇಕ್ ದಿಸ್ ಆಂಬರ್ ಅಂಡ್ ರಬ್ ಇಟ್ ವಿತ್ ದ wool loses the electrons and becomes positively charged, whereas this amber gains the electrons and becomes negatively charged. And we have certain examples, we can go through those. And then we discuss about the charges are at rest, and these will get transferred from one body to another body, and because of that there will be electrification of the bodies. Then what are the properties of charges? So coming to that, we have basically there exists two types of charges, namely positive and negative charge. And whenever we take the like charges, that is positive and positive charges, they will repel with each other. Negative and negative charges, they also repel with each other. When I take a positive charge and a negative charge, they will attract with each other. That means like charges will repel with each other, whereas the unlike charges will attract with each other. And this charge is a scalar quantity. That means charge have only magnitude, it is not having any direction. You may get confused that there are positive and negative charges. These are polarities. Positive and negative is polarity, not the direction. And then coming to the next property of the charge is additive in nature. That means if we have a charge of 2 coulomb, another charge of 5 coulomb, another charge of minus 3 coulomb on a body, then the net charge on the body can be easily calculated by just adding these charges. That is, for example, I am considering 2 coulomb, 5 coulomb, minus 3 coulomb. If I add all these, we get 4 coulomb. It is the net charge on the body. That means I can consider charges are additive. And charge is quantized. When we comes to the word quantized refers to steps, in steps. For example, if I consider a digital clock, I can consider 1 second, 2 second, 3 second. I can't consider 1.5 second like that. That is quantized. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಐ ಕನ್ಸಿಡರ್ ಸ್ಲೈಡ್, ಜಾರುಬಂಡಿ ಅಂತ ಕರಿತೀವಿ, ಅದರಲ್ಲಿ ರೈಸಿಂಗ್ ಏನಿದೆ, ಐ ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ ಫಸ್ಟ್ ಸ್ಟೆಪ್, ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್, ಥರ್ಡ್ ಸ್ಟೆಪ್ ಲೈಕ್ ದಟ್ ಈಸ್ ಕ್ವಾಂಟೈಸ್ಡ್. ಬಟ್ ವೈಲ್ ಕಮಿಂಗ್ ಡೌನ್ ಐ ಕಾಂಟ್ ಸೇ ವೆದರ್ ವೇರ್ ಐ ಆಮ್ ದೇರ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ, at what point I am exactly there, I can't say that. That is not quantized. Rising ಅಲ್ಲಿ 1 step 2 step ಅಂತ ಇದೆಯಲ್ಲ, that is quantized. Or I can consider if you are traveling in a bus and because of something, some problem in the bus, you have to get shifted to another bus. If there are 20 students traveling in a bus and these students have to get transferred to or shifted to the other bus, there you can get shifted as 1 student, 2 student, 3 student, 4 student can get transferred or shifted, not as 1.5 student, 2.5 student. We can't split the student into parts. That means charges can be transferred from one body to another body as a whole, not as part of the charge. This is nothing but charge is quantized. That means charges can be transferred in the integral multiples, that is 1 charge, 2 charge, 3 charge, like that. So I will consider the total charge is equal to n into e, where n refers to integer which get the value of 1, 2, 3, so like that. And the next property of charge is conserved. As we have the law of conservation of energy, energy can neither be created nor be destroyed, but it can be transferred from one form to another form. Here this charge is conserved. That means charges can neither be created nor be destroyed, but these can be transferred from one body to another body. This is nothing but charge, the conservation of charge. And the seventh property of the charge is it remains unaffected by the motion. If the charge is at rest, it will be having same value. If the charge is in motion, obviously it will be having the same value. That means charge remains unaffected by its motion, or it does not change with the velocity. These are the properties of charges. And next, let's move on to the Coulomb's law. In the earlier slide, we have discussed that the like charges will repel with each other and unlike charges will attract with each other. But we didn't say with what force they will get repelled or with what force they will get attracted. This magnitude of force of attraction or repulsion is given by Coulomb's law. According to the Coulomb's law, if I consider the two charges here on the screen, I can see there are two charges q1 and q2 which are separated by a distance r. If I consider like that, then the force of attraction or repulsion between these two is directly proportional to the product of these two charges and inversely proportional to r square, that is square of the distance between them. So we get F is proportional to q1 q2, F is proportional to 1 by r square, where we get F is proportional to q1 q2 divided by r square. Or by including a constant, Coulomb's constant, I would like to replace the proportionality with a proportionality constant. So we get F is equal to K into q1 q2 by r square, where K is called Coulomb's constant and whose value is equal to 1 by 4 pi epsilon naught, which is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square, where this epsilon naught refers to the permittivity of the free space. Thank you.